Okay, everyone, welcome back. We're in grade 5. This is the unit review. At the last one, I made a mistake and said we were starting on number 6. No, we're starting on number 4. Sorry about that. It's number 4 we're starting on. And thank you to Isa2, shout out to her for requesting this question. So, number 4 is about a rectangle. And in this rectangle, the height of the rectangle is 2, and the base, in this case, they wrote the base up on top, and that's okay, because we know a rectangle, the top base is the same as the bottom base. So it wants us to find the area of these two rectangles or together, but do it in two different ways using the distributive property. So we are going to use these numbers. Now, the tricky thing about our book sometimes is that it gives us these tile choices, which sometimes actually confuse kids more than help them. So these are just supposed to help you. You don't have to use all of them, and you don't use them in this order. They just want to start giving you some ideas to help you. And sometimes it's harder. So if these tiles are confusing you, then let's just find area in the way we know how to do it and not let that confuse us. Now, we've got a couple of choices. We could find the area of this small rectangle and then the area of this big one and put them together. Or we could just find the area of this big one altogether. Let's start with the small and small. So, how are we going to find the area of this? Well, we know that for rectangles, area is what? I hope you said base times height. So area equals base times height for a rectangle. So our base in this case is 2. Our height, x. Our height is 2. So for this area, it's 2 times x, 2x. That area is 2 times x, 2x. And then we're going to label it as square units. What about this area? Well, we know the base is 5, and we know the height. If the height over here is 2, we know that means the height here and here are also 2 because it tells us it's a rectangle. So 2 times 5 is 10. So 2 times 5, and we know that's going to equal 10. So then if we put those two together, this one we can't completely solve. We can't get rid of that x because we don't know what x is. We got to just keep x in it. This is one of those times where it's going to be a little tricky because our answer still has letters in it. It's not a completely just number-oriented answer like sometimes we're used to seeing. So we're going to keep this 2x, and then we need to add it. When we put two things together, that's adding. So we're going to add it to 10. That's our answer. And then we're going to write it as square units because we know anytime we're talking about area, it's square units. So 2x plus 10 square units. That's our answer. Now it wants us to give another way to write that same answer. Can we write it another way using the distributive property? We can. I'm going to erase just a bit so we have some more space to work, and I'll be right back. Okay, you can see what I did. I just shrunk up the work that we did. I just shrunk it up so we have more space. Because now we're going to solve it using the whole outside of the rectangle altogether. We're still going to use base times height. So we still need the base, and we still need times the height. So in this case, the base has an x and a 5. How are we going to work with that? We're simply going to do x plus 5. So the base is x plus 5. I'm going to put that in parentheses because that's an important part of something that we need to know that that's all together. That's the base, x plus 5. Now, what's the height? Well, the height tells us it's the same. So I'm going to put that 2 out in front. That's the coefficient. And it's out front because remember, anytime a number and a parenthesis are squished right next to each other, it means multiplication. There's an invisible time sign there. We'll write it in just to help us. So this means 2 groups of x plus 5. Now, up here, we had 2x plus 2 times 5 equals 10 for 2x plus 10. This is another way to write that same area. So area equals 2 times x plus 5 square units. That's using the distributive property. We're going to redistribute some of the numbers. So it's thinking of it in two different ways, thinking of it as a whole thing or thinking of it broken up into chunks and chunks. So those are the two different ways to write the same area. Okay, so this question 4A says represents the area. Which one of these represents the area as the sum of two terms? Remember, terms means something is added or subtracted. So this area is the sum of two terms. 2x is a term and 10 is a term. So it's the sum of two terms. So that's 4A. 4B says represent the area as a product. That means multiplication. A product in which one factor is a sum. So a product, these two are multiplied together, that's a product. And one of the factors is a sum. There you go. 4C, we already talked about when we drew this whole picture. So 4C, make sure you're drawing the picture to show us the two different ways you found it. Okay, we're back with number 6. So shout out to Lucas for requesting number 6. Great job, Lucas. Thanks for getting started with number 6. Number 6 is about surface area. And it's been a little bit of a while since we've done surface area. But let's pause and remember that surface area is kind of like the colored space, the painted space on the outside of a box, if we remember that. Now, that surface area is about a cube, and my example here is a butter container, but it's the same thing. Remember that any three-dimensional shape, when we open it up and lay it flat, we call that the net. So the net is this flat shape. The surface area is the colored space on each of these. So the surface area of like this side, this side, this side, this side, and then of the ends too. That's the surface area. How do we find area? Area, as we remember, is base times height. So we've got base times height of this little part, base times height of that part, this part, base times height, base times height, base times height. So this question wants us to think of that. How much would be painted on this cube if we laid it out flat like a net and then assumed that all of these, just this side, not the other side, because companies don't paint the other side. It doesn't make sense for them to spend the money because nobody sees the other side. They only paint the outside because they want us to, be attracted to the box. They want us to notice it and grab it instead of somebody else's kind. So we need to find the answer to which of the ones that have chosen. They've given a bunch of examples of things that could give us surface area, and they want us to say which ones make sense. So it's either yes, it represents it, or no, that would not help us find it. So let's first of all talk about how we would find it. Well, this side is S, and they're doing a side, and I don't like the variable S. Do you remember why? Looks like a 5. So it's really hard to tell. Is this a 5 or is it an S? Well, in this case, it is an S. It means the side. So this is the side, S. This is the side, S. So they're the same. They tell us it's a cube, and they're the same. So in order to find the area of just that one little cube, we would do base times height. Remember, because the area of a rectangle is base times height. So we would do base times height to get this little here. So that would be S squared. Okay, so these are the choices that our book is giving us. S cubed, 6S means 6 times S. 4S to the 4th power means 4 groups of S to the 4th power, S times S times S times S. 6 groups of S squared, 2 groups of S squared plus 4 groups of S squared, or S squared plus itself 6 times. So we have to see which one makes sense with this picture. So if this is S squared, we know that every single one of these is also S squared. And we are interested in, remember, just the front just that one side. So if this is s squared, we right away could say, look at this, s squared plus s squared plus s squared. Does that make sense with our drawing? Makes a ton of sense with it, doesn't it? So we know that that one is a yes. That one's going to go in the yes column. Are there any other ones that we notice right away are going to go in the S column? Well, hopefully you're saying, I know that when a number and a letter are squished right next to each other, it means multiplication. So I know this means 6 groups of s squared. There's an invisible multiplication sign in there. This is 6 groups of s squared. We're adding them together. 6 groups. Remember, multiplication is just repeated addition. So 6 groups of s squared. We know that one also works because there's 6 different squares, and their area of each one is s squared. So we know that's also a yes. Anything else that immediately pops out to us? Well, what about 6 times s? 6 groups of one side. It doesn't really make sense, does it? 6 groups of one side would be s, 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 s. That's actually only part of the perimeter. 6s would give us a portion of the perimeter. That's not going to give us surface area. So we can cross that out. Put that on the no side. That doesn't represent it. What about s cubed? Do you remember what cubed means? That's volume. That's how much would fit inside. Now, I guarantee you that when the butter company is making this, they're thinking about how much fits inside because it's what's inside that they're really trying to sell us. They want to know how much butter they're going to sell us. So they want to know the amount that fits inside. But length times width times depth, that's a volume measurement. So s cubed, we don't want the volume. We don't know how much wants to go in. We don't want to actually know how much butter we're going to use. We want to know what's on the outside, how much paint they're going to use to paint the carton. So s cubed is volume. That doesn't help us. Let's look at this one. 2 groups of s squared plus 4 groups of s squared. Well, let's look at this. 2 groups of s squared plus 1, 2, 3, 4 groups of s squared. That one works, doesn't it? You bet. So we only have one left. 4 groups of s to the 4th power. Remember, s to the 4th power means s times s times s times s. And we're taking 4 groups of it. We're only doing s squared and having multiple groups of s squared. So that doesn't make sense for us. So you can take those and put them in the correct represents or doesn't represent. Okay, the last one for this video is number 9. Shout out to Jackson. Thanks for requesting this. This is number 9. This is an order of operations question. Now, this is a tricky one because it doesn't ever tell us what x is. So we can't stick a number in for x and find an overall solution. That's not what this problem is asking us to do. It's just asking us to put together like terms. Remember, algebra very often is about a matching game. It's kind of like the old-fashioned when you were kids, like which 2 things go together. So we're looking at this whole expression here and looking for how can we simplify it? How can we shrink it down and put things that are the same together? So 8x means we got 8 groups of x plus 6 squared plus 2 groups of 3 groups of x. We've got 2 groups of 3 groups of x. And then we're subtracting 36. So let's see if there's anything that we can solve, little tiny parts that we can solve. And then let's also see if there's anything that we can match to connect or put together like terms. So the first thing we always solve is parentheses. Here's our parentheses. Within 3x, we can't actually solve that, but we can solve the part that's connected to the parenthesis. We can solve that part, 2 groups of 3x. If I had 3x right here, 3 groups of x, there's one, and I have another group of 3x right there, can I put them together? You bet. They're both x. They have the same number. There's 3 of a mystery number. There's another 3 of a mystery number, 2 groups of a mystery number. Let's put those together. When we put them together, what does it give us? 6x. So remember, when we're doing an order of operations problem, we just keep doing like that old game that you may have played, video game like from my era, where the things just keep drifting down and you're trying to blast them. And as you blast them, then they disappear, but everything else keeps dropping down. So we're going to still drop down the 8x. We're going to drop down the 6 squared. But now we're going to solve this part, 2 groups of 3x. Well, that's 6x. And we're going to drop down the minus 36. We still have all those other parts. The only one that we changed or got rid of was that. Now, we'll look here. Do we have any more parentheses? No. Do we have any exponents? Yeah, 6 squared. Remember, exponents mean the base, the big number, times itself, however many times that little number says. That's the exponent, how many times. So this is 6 times 6. So let's go ahead and solve that. What is 6 times 6? 36. So I keep the 8x. I change this exponent now to 36. And I haven't done anything with the rest of those, so I just keep dropping them down. Now I have 8x plus 36 plus 6x minus 36. Here's our matching game. Is there anything that we can match up? I hope you're saying, yeah, this 8 group of a mystery amount and 6 groups of a mystery amount. We can put those together. Here's our 6 groups. We just need to put that with, which I don't have out right now, 8 more packages of our fruit snacks. So we have 6 packages of mystery amount. We bring out 8 more packages, and what do we have? Well, I hope you're saying we have 14 packages of a mystery amount. Now, if I'm adding 36 and also taking away 36, what is adding 36 and taking away from 36? Hopefully you're saying 0. If I have 36 minus 36, it's 0. So we could, if it's helpful, you could put plus 0. But you don't need to because it's only 0. So you might just say 14x. And then you might say, I don't know what else to do with this. And you're right. You're done. It doesn't ever tell us, and I want to just double check. Nope, it never tells us what x is. So this is just the answer. This is just what they were looking for. They wanted us to take this whole thing and simplify it to be that there's 14 groups of a mystery number. When we come back, we'll do additional numbers later on in the unit. So watch our next video for help on other questions. Thanks. See you next time.